Hello everyone, welcome back. So in this video we are going to understand Leetcode problem number 2872 and it's a today contest problem. So in the daily series, and this is the maximum number of K-divisible components. Okay, so try to understand. It's very simple, not too hard, but if you are really knows the basics, right, so you will definitely will understand. So डरने की जरूरत नहीं है. I have made it very simple. Okay, so keep watching and I will definitely will explain you in very simple language, right, as well as I have created the video in such a way that you will definitely will understand. और लास्ट में हम इसे कोशिश करेंगे अच्छे से अच्छे कवर करने के लिए, आपको समराइज करने के लिए. सो कीप वॉचिंग एंड इफ you have any doubt, please write the comment and I will definitely give the answer there. And in case if you need any help, you can ping me in the comment box. You can join through the WhatsApp and you can do the inquiry or anything if you need. But अगर आप ये वीडियो आपको अच्छा लगे तो प्लीज़ सब्सक्राइब करें and follow me through the subscribe button so you can never forget uh, any video from us. Okay, let's try to understand. So the question is saying that there is an undirected tree with n nodes that is level from 0 to n minus 1. So you are given a integer n and a 2D integer array that is called edges of length n minus 1, where edges at I definitely is having two nodes a and b. It indicates there is an edge between nodes a and b in the tree. You are also given a zero indexed integer array that is called values of length n, and values at I is the value associated with the ith node and an integer k. So valid split of the tree is obtained by removing any set of edges, possibly empty, from the tree such that the resulting component of all the values that are divisible by k, where the values of the connected component is the sum of the value of its nodes. And then we have to return the maximum number of components in any valid split. So as I told you, no need to worry, keep watching. So this is example we have. So if you split this array, not tree, it will look like this. Okay, so we'll try to understand their input and we'll try to understand how to implement such a type of problem. Okay, सबसे पहले हम ये देखेंगे कि इस प्रॉब्लम में क्या कहा गया है, राइट, व्हाट वी हैव गिवन. So the problem saying that the maximum number of k divisible components we have, right? So what we have given, हमें क्या दिया हुआ है, we have given an undirected tree with n nodes from 0 to n minus 1 labeled, right? इसका मतलब क्या होता है कि it means that the tree with n nodes. So we have given n nodes of a tree, right? So how many edges will be there? If the node has n nodes, the edges should be n minus 1 and no cycle is there. Okay, so each node I has a value that is called value at I, an integer k. This is what we have given. हमें क्या दिया हुआ है, हमें ट्री दिया हुआ है, हमें नोड की वैल्यू दे रखी हुई है, कहाँ पे, एक अनदर हमें अरे दिया हुआ है जिसके वैल्यू एट आई को बोलेंगे नोड्स वैल्यू, एंड इंटीजर के वी हैव गिवन, राइट. दिस इज व्हाट वी हैव गिवन. Now understand what is a component, right, before understanding anything in this here. So अगर आपने basically आपने ग्राफ किया है, right, if you know the basic concept of graph, right, so you will understand the concept of component. Okay, so let's try to understand. A component is just a connected part of the tree that is called subtree. If you want a subtree of a tree, right, means we will say a component is just a connected part of a tree, right? It is not separated component. I am talking about the component, right? So component क्या होगा, किसी ट्री का एक पार्ट होगा, राइट, जिसे हम सब ट्री बोल सकते हैं. जैसे एक नोड हम एक नोड से उसके सब चिल्ड्रन को अलग कर देते हैं, राइट, दैट इज बिकम द सेपरेट कंपोनेंट. बट इफ you are considering not the parent root, right, but other roots, right, that is called subtree, right. So that is called a component, right, it's just a component. So all the components connected. So we are allowed to remove some edges from the tree, राइट, हम क्या कर सकते हैं, कुछ एजेस को हम रिमूव कर सकते हैं, कहाँ पे, ट्री, जो हमें ट्री दिया हुआ है, राइट। When we cut the edge, the tree breaks into multiple connected components, right? So you understand, right? So if we cut the any edges, right, definitely it will break into the component, right? So for each component, we can sum all the nodes value inside it, right? And then we'll check the divisibility and other things. So what is our goal? Our goal is to cut the edge in such a way, मतलब कि जो हमारा गिवन ट्री है उसे हमें कट करना है किसी एज के थ्रू, so that the number of connected components whose sum is divisible by k is as large as possible. We have to cut in such a way, right? We have to cut the tree, or you can say the edge, in such a way that the tree components should be maximized and should give the maximum result, right, of the sum. And so we, that sum should be divisible by k. सम कुछ भी हो सकता है, बट हमें कंसिडर वही वाला करना है जो डिविजिबिलिटी को दे, राइट। एंड देन वी विल रिटर्न द मैक्सिमम नंबर हियर। सो रूल क्या है, राइट, हमें रूल दिया हुआ है कि वी कैन कट 0 और मोर एजेस, वी कैन कट एनी नंबर ऑफ टाइम, राइट। ओनली कंपोनेंट हुज सम इज डिविजिबली बाय k शुड बी इक्वल टू 0, मीन्स कंप्लीटली डिविजिबल हो। जो मोड हम निकालेंगे सम और k का, तो रिमाइंडर हमें 0 मिलना चाहिए, मीन्स इट शुड बी डिविजिबल, एंड दैट कंपोनेंट इज कॉल्ड गुड। समझ में आया? अगर हम क्या करें, हम कट कर ले उसको, राइट, और कट करने के बाद जो भी कंपोनेंट बनता है, अगर उस कंपोनेंट का हम सम निकाले, राइट, द वैल्यू ऑफ द नोड वी कैन से, देन जो सम है वो, या उसके अंदर हम अगर मोड लेते हैं, राइट, देन वी शुड गेट द रिमाइंडर 0, मीन्स इट शुड बी डिविजिबल, और उस कंपोनेंट को क्या बोलेंगे, गुड कंपोनेंट। वंस अ कंपोनेंट इज गुड, राइट, वी डोंट केयर अबाउट इट्स इंटरनल स्ट्रक्चर एनी मोर, इट्स काउंटेड एज 1। किसी भी स्ट्रक्चर में हो, डजंट मैटर, वी विल काउंट एज 1। So all the good components is connected as a good component counted as a 1. वेरी सिंपल रूल, हम किसी नंबर ऑफ एजेस को ब्रेक कर सकते हैं, कट कर सकते हैं, देन हमें फाइंड करना है गुड कंपोनेंट्स, हाउ विल फाइंड दैट, लाइक दैट, एंड हमें कंपोनेंट को देखना है कि वंस अ कंपोनेंट इज गुड, सो इट्स काउंटेड एज अ 1। अब हम बहुत कुछ सीख लिए, समझ लिए, राइट, थियोरटिकली। लेट्स ट्राई टू अंडरस्टैंड विजुअली। सो n इक्वल टू 5 है, राइट, एंड वैल्यू लेट्स सपोज वी हैव गिवन 2 3 1 4 2। ओके, दिस इज व्हाट वी हैव गिवन। इसका मतलब क्या है, अगर इस नोट्स वैल्यू को रिप्रेजेंट किया जाए इसके इंडेक्स को, राइट, 0 1 2 3 4, so nodes from 0 to 4 having the value 2 3 1 4, so if I will represent this into a tree, so 0 को हम क्या करते हैं, इंडेक्स 0 है, द नोट्स 0, उसको कंसीडर करते हैं रूट, this root, right, and what is the value is 2, as you can see here, right. Then it is connected to 3, no, second node, right, second node is node value 1, so its value is 3, and similarly we'll connect 1 to 2 and 1 to 3 and 3 to 4, and all these values should be connected, so all the nodes is represented like this, right, and we have also given k equal to 3, right. So what are the edges are there? Edges are there in the trees 0 to 1, 1 to 2, 1 to 3 and 3 to 4, right? Means 0 1, 1 2, 1 3, 3 4, right? This is what we have given, right? So अगर हमें इस तरह की वैल्यू दे रखा है, n इक्वल टू 5, वैल्यूज भी है गिवन है, k इक्वल टू 3 दिए हुए, लेट्स सपोज। सो हमें समझना चाहिए कि जो भी इंडेक्स दिया हुआ है वो नोट्स हैं, राइट, और उसको रिप्रेजेंट कर सकते हैं इस ग्राफ में। Once you represent this graph, so you will understand the edges, right, or you can say if you have the edges, you can represent this graph also, right. But if you will break from here, here, or anywhere, the sum should be equal to the divisible by k, right. So we'll understand. Let's go through the step 1. So think in terms of subtree and sum. So if you consider this array that we the tree that we are talking about, we will do a BFS from the root node 0. So at each node we compute the sum of its subtree, the node and its descendant. मतलब हम लोग क्या करेंगे, एक डीएफएस अप्लाई करेंगे इसके रूट नोड पे, राइट। एंड एट ईच नोड हम लोग क्या करेंगे, वी विल ट्राई टू कंप्यूट द सम ऑफ इट्स सब ट्री. So let's suppose we'll go from here to here, we'll find all this sum of this subtree, right? Like that we will do. And similarly we'll go to here, we'll find this one like this. So हम क्या करते हैं, start करते हैं very beginning 2 से, right? Let's start talk about node 2. If node 2 having the value is what is 2, right? Subtree means we are talking about 2. So node subtree is 2. What is the sum? Sum, if you see, sum is getting 1, so the value is 1. Node 4 will check, okay, what is the value is there, 4 is there, so sum is 2. So is it divisible by 1? Divisible by 3? No. It is divisible by 3? No, right? So who is divisible by 3? Other nodes. Let's suppose 3 we have, 1 we have, and 0 we have. Similarly node 3 having 3 and 4, if you go here, so 3 and 4 is connected here, so we'll consider these 3 and 4, and so we have to do the sum, right? That is why we have to do sum 3 and 4 subtree having two nodes 3 and 4. We'll do the sum, right? Definitely we'll get the value, right? Similarly for 1 and 0 you will find. So if you want to check the subtree sum having divisible by k is this node 3 and node 0, because it's a 6 and 12. 6 and 12 is divisible by 3, right? So that is why we can say there is two nodes, right, that is divisible by this. So we want to cut the edges in a way that maximize the count of such divisible component, right? So in the step 2 we'll say, okay, where to cut it. So look at the node 3, right? So when we talk about node 3, right, so the subtree of the node 3, we know that we have a 6, right? And so that means we could cut the edge between 1 and 3. So we will cut between 1 and 3, right, here, from here. So it will become two component, 3 4 alone, and these 3 is alone, right? So now what we remains, we remains is 0 0 1 2 and 3 4. So these are the separate components, and this become a good component because 4 and 2 is 6, and it is divisible by what, 3. And if you do the sum of these, it's also divisible by this one, but we'll talk about later. So now consider the remaining part which is rooted at 0, right? So remaining nodes is what, 0 1 2, right? 0 1 2. So we have already seen that this is a good component, right, because its sum is this one. Now we'll talk about this one. So what is the value is there, 1 plus 2 plus 3 is 6, right? So we are getting the 6 here. It is divisible by what, k equal to 3, means it's also a good component. So how many good components are there? This component and this component. So if you say component this one and this one is two components, the both are divisible, and so both are valid. And so how many components are there? Two components. So these two valid components will return as a count, and we'll say, okay, this is a valid component, and we'll say return this value as an answer. Okay. Now think about that. We will create a class, and this class will contain graph, value, and a k. So we will use the DFS approach, and we'll say, okay, uh, we have the three values, we have n, is, and values, right? So we will, very first what we need to do, we will initialize this value through the loop, right? And we know that we have the given values there, right? So we'll initialize this date value at I is value at I, right? And then we'll build the adjacency list. So we'll say, okay, graph is equal to what, new array list, and then we'll create the adjacency list, right, we can say. And then we'll go through all the edges, so we'll build the edges, right? Now if you see the count, right, it started with the 0, right, but DFS will start from 0 to -1. So 0 is the root node, so we'll start from the root node and we'll return the count once we will apply for all the nodes. So we know that how to traverse, right? So to traverse that, very first we'll start from 0 nodes, and this is our DFS method. So this DFS method will go from node 0, and it will keep moving to the next node. We know that, right? So very first what we have tried to do, that we have used these values. मतलब हमें पता है ग्राफ, वैल्यू एंड के एंड काउंट, दीज थिंग्स वी रिक्वायर्ड, राइट? सो हम क्या करेंगे, क्लास लेवल पे इसे डिफाइन कर लेंगे. ओके, देन विल से ओके, वी हैव के, वी हैव वैल्यूज, वी हैव. सो वैल्यूज को क्या करना है, हमें अपडेट करना है इन सच ए वे दैट इट्स वैल्यू विल बी गेट अपडेटेड, राइट? सो हमें क्या करना है, बेसिकली हम कॉपी कर रहे हैं वैल्यू यहाँ से. ओके, then we are building the graph. So you are also building the graph. Okay, how we are building the graph? You know that we will initialize each value, right? So adjacency list अगर हमने define कर लिया तो हमें edges मिल जाएंगे, right? From where we'll build the adjacency list. Once you build the adjacency list, what you need to do, just add the u and v. So हमें edge build up कर देते हैं यहाँ पर, एक ऐसे हम edge build करते हैं, ऐसे adjacency list build करते हैं और ऐसे हमें edge build करते हैं. Okay, so reverse, because it's a unidirectional, not both directional, right? So we'll say okay, bidirectional, so you will add uv and vu like that, and start with the count 0 and 0 1 is a root node. अब क्या करना है, मैं root node pass करना है. Let's suppose node, and what is the parent? So parent node doesn't have any parent, right? Root node, so we'll say -1. In another cases we'll pass the root node. Why it is important? Because if you pass the graph.node, you will get all the neighbors nodes. So very first you will check if it is parent, you will continue, so don't go back again. So that is why we will pass the parent. मतलब कि अगर हम रूट नोड सिर्फ अगर नोड पास कर देते हैं, पेरेंट पास नहीं करेंगे, तो एक लूप में फंस जाएंगे हम लोग, राइट? क्योंकि हम यहाँ पे विजिटेड नॉन विजिटेड वगैरह नहीं ले रहे हैं, ये ग्राफ है, तो हम ये क्या करेंगे, यहाँ पे एक पेरेंट नोड ले लेंगे, राइट? सो दैट वी विल नॉट गो बैक हियर. देन विल चेक द चाइल्ड सम. सो चाइल्ड सम पास करने के लिए क्या करना पड़ेगा? वी नो दैट दिस इज आवर नेबर नोड एंड द करेंट नोड. So you will pass here and you will traverse the in the DFS way, and you will have the child node, right? So all the child node will get updated like this. So you will get the child sum and you will add on the sum. So final sum you will get. So basically we want to traverse by one. First हम zero node पे जाएंगे, then sub node पे जाएंगे. So node wise we will get, and we will check the divisibility. So we will check the divisibility and we will increase the count. जहाँ पे divisibility आ रहा है equal to 0 means at that particular node, right, we have counted that this subtree is divisible by k. So this, because we are traversing, let's suppose what I'm trying to say, I think we have here, give me 1 second. Okay, let's suppose very first you will start with the 0, right? So you will pass 0 and -1 because this doesn't have any parents, right? So you will count all these sum for this node, right? How? Very first you will go here, right? You will find the value of this, then this, then this, like that. So very first, if you know the child if you know the child value, you can count for the parent, right? So now you know this part sum. So now if you will traverse here, you know that this path value and this path value, so you will get the sum of this value. Like that we are traversing and we will find the value of the sum. समझ में आ रहा है ना? एक एक लेवल पे जा करके उसके सम को हम लोग क्या कर रहे हैं, फाइंड कर रहे हैं. एंड देन वी आर ट्रैकिंग द सम ऑल्सो. अगर सम डिविजिबल हो रहा है, वी विल इंक्रीज द काउंट. सो बेसिकली मैनुअली वी आर नॉट सेटिंग द वैल्यू समवेयर, बट वी आर जस्ट ट्रैकिंग. इफ इट इज डिविजिबल, जस्ट इंक्रीज द काउंट. सो इस ऐसे वे में क्या होगा, हमें काउंट इंक्रीज होता जाएगा, राइट? एंड फाइनली विल रिटर्न द सम बिकॉज वी आर रिटर्निंग द सम. इन दिस लूप वी विल ओनली गो इफ इट इज डिविजिबल बाय दिस, राइट? इज इक्वल टू 0. Otherwise we'll continue the sum, and sum will get increased each time, and will divide only if it is divisible, right? And finally we know that the count is getting updated here, and once all the nodes are done, we'll return the number of count. So we will find, okay, these number of components are divisible. So thank you guys, thank you for watching this video. In case if you need any help, please ping me in the comment box, and please subscribe this channel. Please support Expert Funda. Please subscribe this channel if you have not subscribed. And अगर आप स्ट्रक्चर वे में लर्निंग करना है, यू कैन ज्वाइन माई ऑनलाइन क्लासेस, एंड प्लीज इंक्वायरी इफ यू नीड, राइट? एंड प्लीज कीप सपोर्टिंग एक्सपर्ट फंडा टू ग्रो. एंड थैंक यू सो मच फॉर लाइकिंग द वीडियो. यू आर following expert funda, so please subscribe if you have not subscribed till now. Thank you for watching this video. Please write the comment. You can appreciate me, right? So I can create a better video for you, and all the hard problem will become easy for you. Thank you for so much. Thank you for watching this till now. Thank you guys, thank you for watching this video. If you found this video helpful, please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.